Okay, so when we go to do number 9, we know that the very first step that we have to do on these, when I follow my steps exactly, step number 1 says to simplify the function. So we're going to have to factor and cancel anything that can be factored and canceled. So when I look at my numerator, x squared minus 4x minus 5, I certainly know that that's a trinomial that looks like it's going to factor. So I need two numbers that multiply to negative 5 and add to negative 4. How about negative 5 and positive 1? Okay. And does anything factor and cancel in the denominator? I take out a 2 and I'm left with x plus 1. All right, good. So ding, ding, ding. That means we're going to have a whole. Sometimes I like to come down here and put a star so that I know I canceled something out. So I'm definitely going to go back and figure out what my whole is going to be. Now, I'm going to do my simplified function. So f of x equals x minus 5 over 2. Now, what if I go back and write this a little bit differently? What if I go back and write this, like break this up and write this as 1/2 x minus 5 over 2? Can you guys tell me what this thing's going to graph? What does this look like? Like, what is this in the form of? Yeah, it's just linear. This is just a line. This is just in y equals mx plus b form, but it's a line with a hole in it. Okay, so this is linear, absolutely. So that makes it a little bit easier to tell a few things, like if it's linear, there's not going to be a slant asymptote. Okay, remember, one of the tricks with slant asymptote is that it can't already be linear. So we kind of like that when that happens. So all right, I'm going to move through the steps of solving these things now. Step number 2, 1 was to simplify, done. 2 is to find the x-intercept by setting numerator equal to 0. And remember, if you want to do, some people do this. They go num equals 0, x equals 0, denom equals 0. Like, I see this a lot when people turn in these quizzes and tests because they've reminded themselves about these 3 little tricks right here, that this is what they do. Okay, so numerator equal to 0. We can do that. X minus 5 equals 0 means x equals 5. So 5, 0 is my x-intercept. 1, 2, 3, 4, 5, 0. Okay, so now I'm going to find my y-intercept. And to find the y-intercept, I replace x with 0. So y equals 0 minus 5 over 2. Which is negative 5 over 2, which is actually negative 2.5. That's easier for me to graph. So negative 1, negative 2, negative 2.5. Okay, vertical asymptote. For my vertical asymptote, I set my denominator equal to 0. My denominator is a 2 equals 0. Does that make any sense at all? No? So this is a none. 2 cannot equal 0, ever. Okay, horizontal or slant asymptote. This is when I look at my exponents, and it doesn't matter if you go back to the original or to your simplified one. If you look at the original, the exponent on top is a 2. The exponent on the bottom right there is a 1. So if you're confused about Bobo Botten Eats DC, look up at the board right now and look at what I'm looking at. I'm looking at the exponents. This is a 2, and this is a 1. So am I bigger on top, bigger on bottom, or the same? Bigger on top, in. That means none. In means none. Bigger on top, none. Okay. Remember, this is a wild robot eating our capital. Bobo Botten Eats DC. But this is a none. So there is no horizontal asymptote, and that's when we have to check for a slant or oblique asymptote. However, in the notes on the first page of this section, it says for the slant asymptote, the degree on top has to be exactly 1 more than the degree on the bottom. Check, it is. And it can't already be linear. And we are already linear, so no slant asymptote because we're linear. All right, let's find our whole now. So to find our whole, I take what I canceled out, which was x plus 1, set it equal to 0. So the x coordinate of my whole is at negative 1. To find the y coordinate, I just plug -1 back into my simplified one because it's easier. So -1 minus 5 over 2. -6 over 2, which is -3. So my whole is at -1, -1, 2, 3. Okay? Now, I already knew that my y-intercept was going to be at -5 over 2, didn't I? Because in y equals mx plus b form, the b is the y-intercept, -5 over 2. That's what I got right there, -5 over 2. And what does this 1/2 tell me? What does this 1/2 tell me, guys? Slope, okay? So I need to go from my y-intercept, if I needed to, and go like up 1, which means I'm going to go up to another half, and then over 2. And then up 1, and then over 2. And I can kind of see my line that's being formed here. It's a line with a hole. We knew that was going to happen. Okay, as x approaches infinity and negative infinity. Normally with a line, what are we approaching on each end? Is it my x's are getting bigger because I have a positive slope? Where are my y's going to? Guys, these are also going which way? Positive infinity. And back here, where are these values all going? Negative infinity. So f of x, or you could write y, goes to positive infinity on the right and negative infinity on the left. Okay, domain, normally with a line, it's negative infinity to positive infinity, but what do I have to jump over? The whole. So I got to take out the x value of the whole on the domain and the y value of the whole on my range. So my domain is everything but -1. So using interval notation, we write it like this: negative infinity to -1 and -1 to positive infinity. And then we're going to go negative infinity to -3 and -3 to positive infinity. Okay, let's do number 10. Step number 1 is to simplify anything that can be simplified. Looks like my numerator is good, but my denominator, I can definitely take out an x. And ooh, be really careful here, guys, because when I cancel these x minus 6's, where is my x left at? In the bottom. So 1 over x is my simplified function. Wow, we should fly through this really fast. That looks kind of like the parent function, doesn't it?
Yes.
But it's the parent function with a hole in it because I canceled something out. To find the x-intercept, I set the numerator equal to 0. 1 equals 0 doesn't make any sense at all. There is no x-intercept. Probably means there's an asymptote there. To find the y-intercept, I set x equal to 0. So y equals 1 over 0. Can I divide by 0? Nope, undefined. Nothing. Probably means there's an asymptote there. To find the vertical asymptote, I set my denominator, which is x equal to 0. Easy peasy. X equals 0 is just the y-axis. That's why there was no y-intercept. Horizontal or slant asymptote. I'm looking at the exponents, guys. And all this should be so fast. You should just look up here and go, this is x to the first, this is x to the second. Am I bigger on top or bigger on bottom? Bobo, bigger on bottom. Bigger on bottom, 0. Y equals 0. The x-axis is my horizontal asymptote. If it's Bobo or eats DC, you do not need to worry about a slant. The only time you worry about a slant is if it's bottom. If there is not a horizontal. Okay, let's find the whole. I take x minus 6 because that's what I canceled out, set it equal to 0. So x equals 6. That's the x coordinate of my whole. I'm going to go to my simplified function. Y equals 1 over 6. 6 and 1/6 is the coordinate of my whole. So 1, 2, 3, 4, 5, 6, and up a 6 is just up barely. So I just have a little bitty hole there because I've got to go up a 6. I don't know much about this. I might have to plug in some points. Let's just plug in 1. So that's pretty easy, guys. If I plug in 1, what's 1 over 1? 1. So I know 1, 1 is here. What would 2 be? 1/2. So right here. So this must come around like this. We know what the parent function should look like. It's up on the word wall, and we should know this is what it looks like. And jump over the hole. Remember, the hole's always going to be in the line of the graph. It is a break in the graph. How about -1? When I plug in -1, what do I get? -1. And -2, I get -1/2. So this other side must come around like this. Okay? As x approaches positive infinity and negative infinity, what are my y values approaching? Remember my hint I told you? 0. If there's a horizontal asymptote, 99.9% of the time, those y values are going to be approaching your horizontal asymptote. Okay? Domain. Ooh, what do I have to jump over? I've got to jump the hole, which is at 6. What else? 0. I got to jump the vertical asymptote. So I'm going to go in order. I'm going to go negative infinity to 0. I'm going to jump the asymptote 0 to 6. I'm going to jump the hole and then go to positive infinity. Make sure you go in order, guys, left to right, smallest to biggest. So I go to 0 first, then I go 0 to 6, then I go 6 to infinity. You can't just throw these randomly all down here. You got to go in order from left to right. And on the y one, you got to go smallest to biggest. So both of them, you can just remember smallest to biggest. Okay, range, what do I got to jump over? 0 for the asymptote and 1/6 for the hole. So negative infinity to 0, 0 to 1/6, 1/6 the positive infinity. All right, last one we're going to do together today is number 11. Okay, so, looks like I got some factoring I need to do. I need to take an x squared out of my numerator, leaving me x plus 1. And then I'm going to go to my denominator. The first thing I need to do is take out a 2, leaving x squared minus x minus 2. And then I think that factors again. 2 numbers that multiply to -2 and add to -1. Yeah, x minus 2 and plus 1. Okay, so I'm not going to look at this guy anymore. So looks like my x plus 1s are going to cancel. That's where my hole is going to be. And my simplified function is x squared over 2x minus 2. Okay, so I simplified it. Now I'm going to follow my next step, which is to find my x-intercept, which means to set the numerator equal to 0. X squared equals 0, and to solve for x, since it's a square root, I square root both sides, and 0 can't be plus or minus. So my x-intercept must be right at 0, 0. To find the y-intercept, I replace all of the x's with a 0. So y equals 0 squared over 2 times 0 minus 2. Okay, let's simplify that. 0 over 0 minus 2 is -2. So 2 times -2 is 0. Wait, what's 0 divided by anything? No, 0 divided by anything. 0. So 0, 0 is also my y-intercept. We should have known that was going to happen. If it's the x-intercept, it's also going to be the y-intercept. But it's okay to do the math and make sure. Vertical asymptote. Set the denominator equal to 0. Okay. So I've got 2 different pieces to my denominator. Do you guys kind of see that? So I'm going to set each piece equal to 0. So 2 equals 0. Does that make any sense? No. But x minus 2 equals 0. I can do that, right? So x equals 2. So that's my vertical asymptote. Okay. All right. Bobo Botten eats DC. Let's make a decision. I can just go back to my original real fast and look. There's a 3, there's a 2. Am I bigger on top, bigger on bottom? Bigger on top. What does bigger on top mean? No horizontal, but there might be a slant. Is it exactly 1 bigger on the top than it is on the bottom? Yes. And am I linear? No. Okay. So guys, we're going to have to find our slant asymptote. All right. And here's how we do this. It's a little bit ugly, I understand, but you can do it. Okay. There are not very many of them that this will happen on, but I would like you to practice it on a couple of them. I think there's only one on your homework assignment. Okay. To find the slant asymptote, we have to do long division. Okay. So I have to take what's in the numerator, and it goes on the inside of my little division bar. And I'm going to go ahead and put plus 0x plus 0. Because remember, when we do long division, we got to have all the steps. And then what's in my denominator is what I'm dividing by, and it goes on the outside. But I'm going to go ahead and write it as 2x minus 4 because it's going to be hard to do it like this. Now, remember, our slant asymptote is just going to be a line. It's going to be something in y equals mx plus b form. So I'm not going to get too much happening up here if all I'm supposed to get is something x plus b. So this shouldn't be too hard, okay? And you don't have to worry about a remainder ever. You just, as long as you get the mx plus b part, you're done. Okay, so when we do long division, I ask myself, what do I need to multiply 2x by to get it to be x squared? I need to multiply it by 1/2 x. I love that, right? Good job. I need to multiply it by 1/2 x because I have to turn 2x into x squared. So 1/2 x, and then I take that 1/2 x times 2x, and I get x squared minus 2x, because you got to multiply it times both terms. Remember, parentheses and subtract. This is a 0, which that needs to happen. If that didn't happen, you didn't choose the right thing up here. And then this is plus 2x. So what do I multiply 2x by to get it to be a 2x? Positive 1. So now I get 2x plus 0. Everything is done. I get all zeros down here. Did I get something in y equals mx plus b form? I did. Oh, I'll do this. I'm sorry. I should have done that. Put that 4 there. I'm sure you guys are confused about what I just did right there. This, when I multiply 1 times -4, is -4. I just don't ever worry about the remainder because it doesn't matter. So this is positive 4, which is your remainder, but the remainder doesn't matter. So, okay, so this is y equals 1/2 x minus 1. That's my slant asymptote. So I just graph it like a regular line. I go up to positive 1. And then my slope is up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, and down 1 back 2. And then I'm going to dash it because it's my slant asymptote. It's just a line. No big deal. Just got to find something in y equals mx plus b form. It's also called the oblique asymptote. You don't ever have to worry about the remainder. As long as you get the mx plus b part up here, you're good to go. All right, let's find our whole. So I canceled out x plus 1. So x equals -1 is the x coordinate of my whole. I'm going to go to my simplified function right here. and find the y coordinate of my hole. So y equals -1 squared is 1 over 2 times -1 minus 2 is -3. So that's -1/6. So -1 and -1/6. There's my hole. Okay, now this is a really different one to graph, right? But do you guys remember me? Yes.
Why would it be -1 and then +1/6? Did you plug
So-
in the -1 for this? Oh, you square.
I square it. You're good. Okay. So remember how I told you guys that asymptotes really shape the graph? This is really going to come into play right here because this graph really does look like this right here. Like it's really weird. It shapes right around this way. Like if I plug in a 1, if I get some numbers here, if I plug in 1, it's going to be 1 over, because 1 squared is 1, 1 over 2 times 1 minus 2 is -1, so that's -2. So -1/2, 1 and -1/2, this guy right here. So this comes up like this, comes around, and then goes down like this, right by the asymptote. The asymptotes really shape the graph. Let's plug in 3 and see what can happen on this other side. So 3 squared is 9, and 3 minus 2 is 1, so it would be 1 times 2, which is 2. 9 over 2 is 4.5. So over 3, up 1, 2, 3, 4.5. So you can see it's going to kind of come around and do the same thing on the other side. And this is definitely one that if you were to graph something like this, it would not have to be perfect. I would not look for it to be like every single point in the perfect spot. All right, in behaviors, as x approaches infinity and as x approaches negative infinity, f of x approaches. So what are my y values approaching? Oh, this is really weird, right? But look up this way. Look farthest over as my x's are getting bigger. What are my y's coming up to over here? Yeah, they're also going up to positive infinity, just kind of like a line. And what about back here? Negative infinity. Good. And domain, let's check it out. Domain, it looks like this guy's going back to negative infinity, but I know I'm going to have to jump my hole. And what else am I going to have to jump? The hole and the asymptote. Good. So negative infinity to -1, that's the x coordinate of my hole. -1 up to 2, because that's my vertical asymptote. And 2 to positive infinity. And for my range, I'm going to jump the hole, which is at -1/6. And -1/6. Wait a minute. This is weird. Where does my range stop right here? 0. And 0 is included, right? So I'm going to have to go -1/6 to 0 and include 0. And then it looks like it starts back up again. I've got it at 4.5, but it actually comes a little bit lower than that. And I'll just tell you guys, if I would have plugged in 4, 4, we would have seen that. So 4, 4 is right here. So it goes 4 to infinity. And again, please know that one that's like this, I am more than likely not going to put on a quiz or a test. But I'm not helping you out by not showing you how these other weird ones exist. Okay? Now, the other two that we did today together, those were easy peasy, I thought. Fair game. Okay?